Here we are on this remarkable planet, a world teeming with life, mystery, and wonder. For millennia, humanity has gazed up at the heavens and down at the vast landscapes, asking a most fundamental question: what is the shape of our world? It is a query that has sparked curiosity, debate, and discovery throughout our history. We often assume this question was settled long ago, a relic of a less enlightened time. Yet, in our modern age of satellites and space travel, the debate has been rekindled with surprising vigor. It challenges us to look again at what we believe to be true, to re-examine the very ground beneath our feet and the horizon that stretches out before us. The world we experience in our daily lives certainly appears to be flat. When we stand on a beach, the ocean extends to a perfectly level line. When we drive across a plain, the road seems to stretch into infinity without a hint of a curve. Our senses, the very tools we use to navigate our environment, provide us with this powerful, intuitive impression. This is the starting point for a fascinating journey into two very different ways of seeing our home. It is a journey that pits personal observation against centuries of scientific measurement and exploration, forcing us to consider how we truly know what we know. In one corner, we have the established scientific consensus that the Earth is an oblate spheroid, a slightly flattened ball spinning through the cosmos. This view is supported by a mountain of evidence, from photographs taken from space to the complex mathematics of physics and astronomy. It is the model taught in every school and used to navigate our ships and aeroplanes. It underpins our understanding of seasons, time zones, and the force of gravity. To most, this is not a theory, but an established fact, as solid and dependable as the rising of the sun. It is a triumph of human intellect and our relentless quest for knowledge, and yet, in the other corner, a growing community passionately argues for a different reality. They propose that the Earth is not a globe at all, but a flat, enclosed disk. They suggest that the evidence for a spherical Earth has been misinterpreted or perhaps deliberately fabricated. They urge us to trust our own eyes, to question authority, and to seek a truth they believe has been hidden from the public. This is not merely a scientific disagreement, it is a profound clash of worldviews, a testament to the enduring power of human skepticism and the desire to find our own answers. And so our exploration begins with an open mind and a spirit of inquiry. The idea of a flat Earth is not a new one. In fact, it is one of the most ancient ways humanity has conceptualized its home. For many early civilizations, this was the most logical and intuitive model. The ancient Egyptians, for instance, imagined the world as a flat expanse of land with the sky stretched over it like a canopy or tent. In Norse mythology, the world of humans, Midgard, was a flat disk surrounded by a vast ocean, home to a monstrous sea serpent. These were not scientific theories in the modern sense, but rather cosmological maps that placed humanity at the center of a divine and understandable creation. These early models were often rich with mythological detail. The ancient Greeks, in their earliest philosophies, also conceived of a flat Earth. Homer and Hesiod described it as a disk floating upon a great river, Oceanus. This was a world that made sense from the ground. The sun rose from the east, traveled across the dome of the sky, and set in the west, presumably passing through an underworld to return the next day. The stars were lights fixed to this celestial dome. It was a complete and coherent system, born from direct observation and the human need to create order and meaning from the world around them. However, it was also the ancient Greeks who first began to challenge this view. Thinkers like Pythagoras and later Plato and Aristotle used logic, mathematics, and astronomical observations to deduce that the Earth must be a sphere. Aristotle, around 350 BC, pointed to several key pieces of evidence. He noted that the shadow the Earth casts on the Moon during a lunar eclipse is always circular, a shape only a sphere can consistently produce. He also observed that as one travels north or south, different constellations become visible, something that would be impossible on a flat surface. These were revolutionary ideas, slowly shifting the consensus among the educated. By the Middle Ages, the concept of a spherical Earth was widely accepted among scholars in Europe and the Islamic world. The popular myth that Christopher Columbus sailed to prove the Earth was round is, in fact, inaccurate. The debate at the time was not about the Earth's shape, but about its size and the distance to Asia. The idea of a flat Earth largely faded into obscurity, a relic of a bygone era. Its re-emergence in the 19th and more prominently the 21st century represents a fascinating return to these ancient, intuitive beliefs, now armed with new arguments for a modern audience. To understand the modern flat Earth perspective, one must first look at their map of the world. It is quite different from the familiar globe we see in classrooms. In this model, the Earth is a vast circular disk, much like the emblem of the United Nations. The North Pole, or the Arctic, is located at the very center of this disk. The continents are arranged around it, spreading outwards towards the edge. What we know as the Southern Hemisphere is not a hemisphere at all, but the outer region of this flat plane. This layout rearranges our entire understanding of geography and distance. The most striking feature of this model is what lies at the outer edge. In the place of Antarctica, the continent at the bottom of our globe, flat Earth theory posits a colossal ice wall. This wall, said to be hundreds of feet high, encircles the entire world, holding in the oceans and marking the boundary of our known realm. It is this ice wall that prevents the water from simply spilling off the edge. What lies beyond this barrier is a subject of much speculation within the community. Some believe it is an endless expanse of ice and snow, while others suggest there may be more land or even other worlds hidden from us. Journeys and navigation are explained differently in this model. East and west are not straight lines but circles around the central North Pole. A flight from Sydney to Santiago, Chile, which on a globe appears as a direct route over the Pacific, becomes a much longer journey on the flat Earth map, arcing across the entire disk. Proponents of the theory often point to flight paths that seem unusual on a globe as evidence for their map. They argue that airlines are secretly flying over a flat plane, their routes dictated by this true hidden geography rather than the spherical model we are all taught. This map is the foundational stone upon which the entire modern flat Earth theory is built. It seeks to provide an alternative framework that can explain the world as we experience it. It recontextualizes everything from the movement of the sun to the paths of aeroplanes. Understanding this map is crucial, as many of the arguments put forward by flat Earth believers are designed to demonstrate its validity and to show how the spherical model, in their view, fails to align with reality. It is a radical reimagining of our planet, placing humanity not on a spinning ball but within a vast, enclosed and stationary world. One of the most powerful arguments put forward by the Flat Earth community is based on the principle of perspective and the nature of the horizon. They argue that if the Earth were truly a sphere with a circumference of some 25,000 miles, we should be able to observe its curvature over long distances. According to their calculations, the Earth should curve downwards at a rate of approximately 8 inches per mile squared. Therefore, when looking at a distant object across a body of water, a significant portion of that object should be hidden behind the curve of the Earth. To support this, they point to numerous amateur experiments and observations. A common example involves using high-powered zoom lenses to view objects such as boats, buildings, or oil rigs from many miles away. In many videos and photographs shared within the community, these distant objects appear to be fully visible, sitting right on the water's surface, when calculations based on a spherical Earth suggest they should be at least partially obscured by the horizon. This apparent lack of curvature is presented as direct, empirical proof that the surface of the Earth is not curved but is instead a vast, level plain. Another key piece of evidence cited is the behavior of water. It is a fundamental observation that water always finds its level. In any container, large or small, the surface of still water is perfectly flat. Flat Earth proponents extend this principle to the entire planet. They ask how it is possible for the immense oceans of the world to adhere to the outside of a spinning ball. They argue that gravity, as mainstream science describes it, is not strong enough to hold such vast bodies of liquid to a curved surface. Instead, they propose that the oceans are contained within the basin of a flat Earth, held in place by the great ice wall at the perimeter. Finally, there is a deep-seated distrust of official sources, particularly the space agency NASA. All photographs and videos of the Earth from space are dismissed as computer-generated imagery or CGI. The moon landings are considered to be an elaborate hoax filmed in a studio. This skepticism is central to the belief system as it allows for the dismissal of the most direct evidence for a spherical Earth. By questioning the authenticity of this evidence, believers can maintain that no one has ever truly seen the Earth from a high enough altitude to confirm its shape, preserving the possibility that it is indeed flat. The movements of the celestial bodies present a significant challenge for any cosmological model, and the flat Earth theory offers its own unique explanation. In this view, the Sun and Moon are not colossal bodies millions of miles away, but are instead much smaller, closer objects. They are thought to be spheres, perhaps only 30 miles in diameter, circling at an altitude of approximately 3,000 miles above the surface of the flat Earth. They act like spotlights, illuminating different portions of the world as they travel in their circular paths above the disk. This spotlight sun is used to explain the phenomenon of day and night. As the sun circles above the plane of the Earth, it illuminates the area directly beneath it, creating daytime. The regions outside this cone of light are in darkness, experiencing night. The seasons are explained by the sun's path changing over the course of a year. In the summer, the sun's circular path is smaller and closer to the central North Pole, bringing more direct light and warmth to the northern regions. In the winter, its path widens, moving further out towards the southern edge, resulting in shorter days and colder temperatures for the north. Eclipses are also reinterpreted within this framework. A lunar eclipse, which mainstream science explains as the Earth's shadow falling upon the Moon, is sometimes explained by the presence of a mysterious, unseen anti-moon or shadow object that periodically passes in front of the Moon. Solar eclipses are similarly explained by the Moon passing in front of the Sun, though the mechanics of how these two small close objects align so perfectly is a matter of ongoing debate and speculation within the community. The goal is to provide a mechanical explanation that does not require a spherical Earth. The stars in this model are not distant suns, but are simply small points of light affixed to a rotating dome or firmament that sits above the Earth. This dome rotates, causing the familiar nightly progression of the constellations across the sky. Polaris, the North Star, is positioned directly above the North Pole at the center of the disk, which is why it appears stationary while all other stars circle around it. This celestial arrangement paints a picture of a contained geocentric system, a sort of terrarium-like world where humanity resides at the very center of creation. But, in stark contrast, the scientific consensus, built upon more than 2 millennia of observation and calculation, describes the Earth as an oblate spheroid. This means it is mostly spherical but slightly flattened at the poles and bulging at the equator, a shape caused by its rotation. This model is not just an idea, but a cornerstone of modern physics, astronomy, and geology. The evidence supporting it is vast and comes from many different fields of study, creating a coherent and interlocking picture of our planet's place in the solar system. One of the most direct and easily verifiable pieces of evidence is the way ships disappear over the horizon. When a vessel sails away from shore, it does not simply get smaller and smaller until it vanishes. Instead, it appears to sink, hull first, below the horizon line. The last thing to disappear is the top of its mast. This phenomenon is a direct visual confirmation of the Earth's curvature. It is precisely what one would expect to see on a spherical surface. Conversely, an observer on a tall cliff or lighthouse can see further than someone at sea level because their higher vantage point allows them to see over more of the curve. Furthermore, the existence of time zones is a simple, everyday proof of a rotating, spherical Earth. It is noon in London while it is still early morning in New York and evening in Mumbai. This is only possible if the sun is illuminating different parts of a rotating globe at different times. On a flat Earth with a spotlight sun, the transitions between day and night would be much softer, and the sun would be visible in the sky even from areas in darkness, albeit appearing very small and dim. The sharp, defined terminator line between day and night seen from space is a hallmark of a sphere being lit by a distant light source. The force of gravity also provides compelling evidence. On a spherical Earth, gravity pulls everything towards the center of mass, which is why down is always towards the ground, no matter where you are on the planet. In the flat Earth model, explaining gravity becomes problematic. If gravity worked the same way, it would pull everything towards the center of the disk, the North Pole, meaning people in Australia would feel a sideways pull. To counter this, some flat Earth proponents propose that the disk is constantly accelerating upwards at 9.8 meters per second squared, creating the illusion of gravity, but this introduces a host of other scientific impossibilities. When we place the two models side by side, the scientific explanations for common phenomena appear more robust and consistent. Let us return to the argument about seeing objects at a distance. While powerful zoom lenses can indeed bring distant objects into view, they do not eliminate the effects of the Earth's curvature. The phenomenon of atmospheric refraction, where light bends as it passes through layers of air with different temperatures and densities, can play a significant role. Under certain conditions, especially over cool water, light can bend downwards around the curve, making objects appear higher than they are and creating a superior mirage. This explains why curvature is not always observed as predicted by simple geometry. Air travel provides another powerful refutation of the flat Earth map. Countless commercial flights operate in the southern hemisphere, routinely flying direct routes between cities like Johannesburg, Sydney and Santiago. For example, the Qantas flight QF28 flies non-stop from Santiago, Chile to Sydney, Australia. On a globe, this is a logical direct flight over the southern Pacific and Antarctica. On the flat Earth map, this journey would require flying across the entire disk, passing over South America, North America, and the Pacific Ocean, a route that would take far longer than the recorded flight time of approximately 15 hours. The existence of these flights is simply incompatible with the proposed disc-shaped world. The behavior of a Foucault pendulum is another elegant demonstration of the Earth's rotation. This simple device, a heavy pendulum swinging from a long wire, will appear to slowly change its plane of swing over the course of a day. In reality, the pendulum's swing remains fixed, and it is the Earth that is rotating beneath it. The rate and direction of this rotation depend on the latitude. At the North Pole, it would make a full 360-degree rotation in 24 hours. At the equator, it would not rotate at all. This experiment has been replicated in museums around the world, providing tangible proof that we are on a spinning sphere. Finally, the simple act of looking at the Moon and other planets through a telescope reveals that they are all spherical bodies. Science operates on the principle of mediocrity, which suggests that our planet is not special. If every other celestial body we can observe in detail is a sphere, it is logical to conclude that the Earth is one as well. To believe otherwise requires one to assume that the Earth is unique and fundamentally different from every other object in the known universe, a position that runs contrary to centuries of astronomical discovery that have consistently shown us our place as just one part of a vast and magnificent cosmos. Comparing the flat Earth and spherical Earth models is like comparing two fundamentally different approaches to knowledge. The flat Earth perspective is rooted in a philosophy of radical empiricism and personal observation. It champions the idea that what you see with your own eyes is the ultimate truth. The horizon looks flat, the ground feels stationary, and water lies level. Therefore, the Earth must be flat and stationary. This approach is appealing because it feels intuitive and empowers the individual, suggesting that complex scientific instruments and institutions are not necessary to understand the world and may even be designed to deceive. This worldview is also sustained by a deep-seated skepticism of authority. It posits a grand global conspiracy involving governments, space agencies, scientists, and airline pilots, all working together to hide the true shape of the Earth. The motives for such a conspiracy are varied, ranging from financial gain to social control. Within this framework, any evidence that contradicts the flat Earth model, such as photographs from space, is immediately dismissed as fraudulent. This creates a belief system that is difficult to challenge with external evidence, as the very sources of that evidence are considered part of the conspiracy. The scientific perspective, on the other hand, is built on a foundation of measurement, experimentation, and peer review. It acknowledges that our senses can be deceiving and that intuition is not always a reliable guide to the true nature of reality. Science uses mathematics, a universal language, to build models that not only explain what we observe, but also make testable predictions. The spherical Earth model, for example, allows us to predict the times of sunrises, the positions of stars, the behavior of satellites, and the subtle variations in gravity across the globe with incredible accuracy. This scientific model is not based on faith or authority, but on a vast interlocking web of evidence gathered over centuries by independent researchers around the world. It is a self-correcting system. New evidence can refine or even overturn old theories. The strength of the spherical Earth model lies in its ability to consistently and coherently explain a multitude of phenomena, from the shadow on the moon to the GPS signal in your car. It is not a conspiracy, but a consensus reached through a long, arduous and global human endeavor to understand our home. Our journey through these two competing visions of our world brings us to a place of reflection. We have seen how ancient intuitions can persist and find new life in the modern age. We have explored a model of a flat, enclosed world built on personal observation and a deep distrust of established institutions. It is a testament to the human desire for answers that feel personal and tangible. The passion and conviction of its believers are undeniable, reminding us that the quest for understanding is a powerful driving force for all of humanity. We have also revisited the monumental achievements of science. We have seen how logic, mathematics, and careful observation, from Aristotle's shadows to the modern-day GPS, have constructed a model of a spherical Earth. This model is not just an image, it is a functional tool that allows us to navigate our world, predict natural phenomena, and venture beyond our own atmosphere. It represents a different kind of truth-seeking, one that relies on collective effort, rigorous testing, and the courage to accept that reality may be far stranger and more complex than our senses suggest. The enduring debate over the shape of the Earth, therefore, is about more than just geography. It is about how we seek truth. Do we rely solely on our own senses and intuition, or do we trust in the collaborative process of scientific inquiry? How do we navigate a world saturated with information, where photographs can be faked and experts can be questioned? It forces us to think critically about our sources of knowledge, to weigh evidence and to understand the difference between a personal belief and a scientifically validated theory. In the end, the world continues its silent, majestic spin through the cosmos, indifferent to our debates. The sun will continue to rise, the tides will continue to turn, and the stars will continue their silent wheel across the night sky. The true value of this exploration may not be in settling the argument, but in sparking curiosity. It encourages us to look up at the sky, to observe the world around us with fresh eyes, and to never stop asking questions. For it is in this relentless quest for knowledge, this unending desire to understand our place in the universe, that we find the very essence of what it means to be human.